Yeah, hello class. How are we? We are fine. We are fine now. Scientifically, we must prove that you are fine, not so? Because you might say you are fine, yet the head is not going to understand. Now, to see that, let's just pose a small logical question. Listen attentively and try to give the answer. It will prove to me that your heads are working properly. The question goes, I have a brother at home, and we were talking the other day, an issue, and he said this. Listen to what he said. The brother is called Sam. Sam said, listen, he said, if yesterday was tomorrow, then, let me write it. Sam said, if yesterday was tomorrow, yeah, that's his statement. Today would be Friday. Today would be Friday. When do you think Sam spoke? When were we talking with him those things? When did Sam speak? When were we discussing? When did Sam say that statement to me the other day? Yes, precious, you seem to have reasoned it out. You told me your head is working properly, but what do you think?
I think he spoke that on Saturday.
It does not seem to be correct. Think and we see. It doesn't seem to be correct. Are you doubting yourselves?
Okay, for me I think it's Thursday.
Thursday?
And for me I think it's
Patience is not correct. Doesn't seem correct. You said Sunday. How did you arrive at Sunday? You are correct. But how did you reach Sunday? Could you reflect?
okay, according to me, actually, I don't know how to explain it.
You don't know how to explain, but you are sure it is Sunday.
Yes.
That means you will get time and explain to the rest. Okay, that's very, very good. That's high level of logical thinking. That means the head is working very, very properly. Thank you very much. Now we can open our topic 9 to really find out, to go ahead with we congratulate you for reasoning very heavily. Now, topic 9 is data collection and presentation. Then we are going to have a few subheadings here, which are subtopics rather. Subtopics. Shall see. We are going to visit definition of key terms here. Key terms. Then we shall also now visit types of data. Then we shall be visiting methods of collecting data, collecting data, and examples here. Collecting data. Then we shall also look at data presentation and interpretation. It's kind of brief. That means that we shall not spend a long time there. Now, this part of data collection is used in a field of science called research. Yeah, that's why we are studying this part at this younger age, so that we can know how to make a research, because we are going to ask you to make some few local investigations in your communities, and you must know how to deal with what we call data. Now let us start with the definition of these terms, since this part is crucial in the scientific world. Definition of key terms, and we are going to define data, and also define what we call statistics. Now, since I told you to go and read before you come in, how many tried to read about data? How many read about what's data? What does that word data mean? Anybody recalls any information on data? To collect data, what's that data? Yes, Grace, you seem to be warming up. What's data, Grace?
Okay, I'm just trying. So data is unprocessed and useful information.
Unprocessed and useful. That means you are using the computer language, unprocessed. That when you have fed information in the computer, then what you have put there is what we are calling data before you can put it out of the computer and it becomes information. Okay. You are using that definition from in the computer sense, that data is unprocessed and useful. That means you feed in the computer, and what is stored in the computer is what we are calling data. Fine, thank you very much. Another somebody is trying?
I think data is any kind of information that is useful, but
any kind of information that is useful. Yeah, that means in research we normally use that word very much to mean any true facts about events. You see that? Yeah, that when I look at you and I say you are black, that is the data that I've seen about you. It means data just refers to facts which can be in form of words. Is that right? They are facts which can be in form of words, numbers, symbols. Yeah. Numbers, symbols. Not so? Now, this information that we observe about objects, after us collecting it, then we subject it to what we call interpretation, and we interpret. If you have black hair, we can categorize you into something. That means we interpret it, discuss it, and we can analyze it. You see that? Yeah, that there are facts in form of numbers, words, etc. 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 Now, let us go to types statistics. What is statistics? What is statistics? Yeah, we need that term also defined, because we are in a research on the topic that deals with basically research. We are not studying it for the sake, but for research. What is statistics? Maybe that one I can guide you, because yes, somebody is warming up. Yes.
Statistics is a subject that deals with exploring, summarizing, and making sense of.
Speak louder.
Information.
Speak louder. A subject that deals with
exploring, summarizing, and making sense of available information.
Okay. Exploring, summarizing, and making use of available information. That's very, very good. You can find it in textbooks and internet. Now we would just summarize it that it is just a scientific method of collecting, a scientific method of collecting, storing, summarizing, presenting information. Scientific method of collecting, summarizing, storing, and presenting information or data. Yeah, or data. Yeah, whether we use data or information, it's fine. Now, I hope that's understood. Now we can drop to types of data, and I'm convinced that since you researched, you know about those types of data and examples. Could we see people helping us? Yeah, questions seem to be on me. We have qualitative data. Qualitative data, then
quantitative data.
Quantitative data. We can start with qualitative data. Since you gave me what's qualitative data, I know you know what it means. What is qualitative data? Yes, only persons knows about it. What is qualitative data? I'm seeing one hand still. What is qualitative data? Okay, you can still go ahead. Others.
Qualitative data is the type of data that is not given numerically. That is to say, it is given in words.
The data that is not given in form of numbers, but it's given in form of words. Yeah, that's a very, very good, simple definition. Yeah. That it's the data which is descriptive, not numerical. Yeah. This is the data which is descriptive or using words, not so? Using words. The data which is descriptive Yeah, it's given in form of descriptions, narratives. You can narrate, not so? You can narrate information about a certain place. Yes, it is narrative, descriptive, not so? Narrative and descriptive. Yes. Now, could we have some, maybe we will give examples generally after us checking through quantitative. Let us check through. What is quantitative data? Data? Yes, let me have Grace.
This is data given
numerically or in form of? Yeah, numerically. And we subdivide it into, yes, types of quantitative data. Quantitative data. What do we have there?
descriptive,
We have descriptive, quantitative, and
continuous, quantitative.
continuous. Can I give somebody 3 minutes? You talk about descriptive data with clear examples. Clear examples. Then we are saying this one is continuous. Yes, who is ready to take 3 minutes? Only keep time. What is discrete quantitative data? Yes, who is ready? Yeah. Patients talk about descriptive quantitative.
Discrete quantitative data is the type of data that takes specific numeric values.
Takes specific numeric values. Yeah?
Just like number of students in class, they are now right here we are.
You are 3.
And you can't say that we are 4.5.
Okay.
There is no half person in this one.
No half person.
Yeah.
Sure. Could we give chance to that? This is data which is what you say. The discrete data is data which checks on specific values. Okay. Okay. Can we have Grace taking on continuous?
Okay. Continuous data is this kind of data that is in a continuous way.
Is in a continuous way.
When we speak of the weight of something or the height of someone, because for instance I can take you teacher, or maybe because if I'm to measure how
You can
weight
take
for
me
now,
teacher or Ruth. Yes.
I can measure her weight for now, and I may measure it maybe 1 week from now. It will be different. Like she may have 23 kgs the mass today, but then tomorrow it may change.
It may
So
change.
It is continuous.
It is continuous. Oh, now that means we can conclude and say discrete quantitative data, this one we say takes on certain values, not so?
Yes.
Specific values, and she counted. That means data that involves what? Counting. Then in your description, Grace, with this data takes on a range, values within a range, values within a range. But you said you can measure. That means the data which can be measured by some form of an instrument, it is continuous. Like you can measure height using a tape measure, not so? You can measure mass using a weighing scale. Oh, that means that this data is obtained by counting. Not so? You can count how many televisions are in the shop. You can count how many people around. You can count cars. Not so? As long as you can count, you are dealing with discrete. But as long as you can measure, could you comment on temperature? Is it continuous?
Continuous.
Because it can be measured and it can vary through a certain range. Okay, now let me pause here. We want to discuss examples here. Now, since you have explained very properly, I want you to how many have a dog at home? Or let's say you have a cow or an animal. Which animal do you have at home? Can you give some data which you tell us the animal you have at home? Then you tell us some qualitative data on it. Which qualitative information do you pick from the animal? Then which quantitative, which is discrete quantitative data on the animal, but you tell us which data will be discrete on the animal and which data will be continuous. Which animal do you have at home? Let me have Precious. Which animal? You have a rabbit. You have rabbits. Which some qualitative data on the rabbit?
The rabbits, some of them are white.
You are describing, you know, so white in color.
Others are brown.
Brown, some are brown.
Most of them are fat.
Yes, she's describing they are fat.
And even they run faster.
Run faster. That's very, very great. That's good description. Now, can we have some discrete on it? Counted things, because this data is involving counting. What can you count?
The rabbits are...
What can you count on the rabbit?
The rabbits have 2 ears.
They have 2 ears. Yes, that's very good discrete.
The female ones have 8 breasts each.
Did you count them?
Yes, I count.
Female rabbits have 80
breasts
each. Go ahead. Then they have 4 legs. That's very, very, very good. That's very accurate. Can you give us some? This is counting. What can you measure on the rabbit?
You can measure their weight.
Weight. That means which weight do you expect your rabbit to be weighing? 6 kilograms. That means one rabbit is 6 kilograms. 6 kilograms. That's very perfect. What else? How long are their ears?
Like 5 centimeters.
5 centimeters each ear. Ears are. Now we would really appreciate Precious. You have really taken us through very perfect data, and that's so accurate, so accurate. Yeah. I'm seeing Grace wanting to take us through. What are you using? The animal or what?
I'm using a bird. It's a hen.
You are using a hen. Okay. She's using a hen here to take us through. Okay, start on.
Okay, the qualitative.
The qualitative part of the hen.
I can speak of the place of birth.
Yes, where was it born? In a toilet or?
No, it was born in a poultry house.
Hey, that means she's speaking about the place, describing the place. Born in a poultry. Okay, go ahead.
Then its favorite food.
Its favorite food now for the bird. What does it eat?
It mainly eats posho that has sauce like mukene.
I like posho with mukene.
Yes.
With mukene. Mukene is which? Silverfish.
Yes. Okay.
What else?
Then I can also speak of their size. They are too big,
Size. That means they are fat.
Yes.
Fat. Okay. Go to discrete quantitative data. What are you speaking about them?
In number, I can speak of their number. It is exact like 50. They are 50.
There are 50 hens
Yes.
at home. Okay.
Then they have 2 legs each.
2 legs each. Yes.
And then
Then lastly, what can you measure? What's the continuous part?
their weight
Weight is
like around 4 kg.
4 kilograms each.
Then we can measure their body temperature.
Body temperature is around which temperature normally?
It depends on the conditions of the day.
Like when had you ever measured and it gave you some?
Okay, because it was hot.
And what was the
I
temperature?
think the temperature was around 30 degrees Celsius.
Or 30 degrees Celsius.
Yes.
Okay. Yeah. Yes, patience. Lastly, what are you using here?
Chicks.
You are using chicks. Do you have some at home?
Enough.
You have enough, moreover. Okay. Chicks. What is the qualitative, the descriptive part of
They are, some are cream, some are yellow, some are black.
some are cream? It means the color is cream, yellow, or black. Then
And they are fat.
size, fatness, fat.
And their dad's color is red.
That's the color.
The chicks.
The father of the chicks. What is the name of that father?
Seko.
Is
And the mother is black, the hen.
is which color? Red.
Yeah.
And the mother is
Black. The hen.
the hen. The mother is black.
They were born in a poultry house.
Place of birth is the poultry house. Yes, go ahead.
And I left home when they were 2 to 3 weeks old.
That the age were 2 to 3 weeks.
Yeah, that's discreet.
You are coming here. Age 2 to 3 weeks.
Yes.
It means you were counting. Okay.
Then they have 1 father.
Number of fathers. She counted that they have 1 father who is a koko.
And in total they are 10.
10. Number of chicks. There are 10 chicks. That's perfect.
Yes. And they have 1 mother.
Have 1 mother. Then go ahead.
And continuous data is that they are around 10 inches.
Their height or length or size or what?
Height or what?
They are 10 inches.
Yes.
Okay. Only that about
Then the
them.
weight,
They weigh
2 kilograms.
2 kgs. Okay, that's perfect. Yeah, I've loved your presentations. Thank you very much. You have been very, very fabulous and bombastic. Not so? Now let us look at methods of collecting data. Methods of collecting data. Now, like, how are you collecting data about your hens, rabbits, and what? Yes, I can see. Let's have Grace, then Patience. You can observe. That means methods of collecting data. Talk about observation. Yes. Measuring. Could we call that one experimentation?
Yes.
Measuring, yes, that's experimentation. Measuring. Yes.
And even asking questions.
That means questionnaire, use of questionnaires. Questionnaire. Not the right spell? Questionnaires. Yes. Interviews. That's very, very, very great. Interviewing. You have more? Researching. Yeah. Searching.
Watching videos.
Aren't you researching? Watching what? Videos.
Okay, like not watching videos. You record a video, then you show it somewhere.
Oh.
Yeah, like recording, watching.
Recording and watching the videos. That's so good. That's very, very good. Now, under here, we shall first define something. There we shall look at what we call a survey. Then we shall also look at what we call a sample, and also look at what we call a census. Have you ever heard of that word, population census? Yeah. Census, what did they mean?
Like the
Population census.
the total number of people living in that area.
Census, that means population census. Census is to refer to, I hope you are very, very attentive, not so?
Yes.
Now, let us start with a survey. To survey is to conduct a research in form of use of questions. That means you go and ask questions from people to collect some information about them. It's the method of collecting data by asking questions. Method of collecting data by asking questions. And that one, it means it will cover your part that you are calling questionnaires and interviews. Falls under what we call a survey. You are surveying, you are asking questions. Now, a sample is yes, I see a hand there.
A sample is like part of a whole used to in an experiment.
It is a part of a whole.
Yes.
That if there are 1,000 people in the village and you wanted to know how many have cars, you either use a sample or a census. A sample, you said it is just part of the whole population. Yes. Then a census it refers to a whole population, while a sample is a part of a population. Yeah. Now, listen. A census is always accurate because if you asked all the people, you would clearly know. But if you asked 10 people and all of them have cars, and you say now all the one south error, not so? That means a sample is less accurate to deal with than a census. Yeah. Now listen. Normally in research, because here we are dealing with research, not so? We are collecting information. Now in research, normally a sample is normally 10% of the population. Did you hear that? 10%, it means if you have a country of 4 million and you wanted to know how many are suffering from COVID-19, you do sample how many? 4 million. And samples are normally 10% of the entire population. Yeah. Is that very correct? Now, yes, I'm about now to ask to give some questions here about a sample, because we have agreed a sample is 10% of a census when you are carrying out a sample research. Also, now let me find out, could somebody, can we answer this? Can answer this? You are ready? Now it is here. There are 800 people living in a town. There are 800 people living in a town. Kenneth wants to know the ages of people in the town. To know the ages of people in a town. Yeah. She decides to ask a sample. She decides to ask a sample of the population. How many people should she have in the sample? Yes, how many people? Grace? 80 people. That will be her sample size. Then you can have this number too. Now you notice that if the sample size is small, do you need to again sample again? Have this. There are 20 students. There are 20 students in Grace's class. And Grace wants to know their favorite color. Should she ask the whole class or a sample? I want somebody to guide us there. Should she ask the whole class or a sample? Yes, Patience. She should ask a sample. Why? Could you give a reason?
Yeah. Because if she starts asking the whole class, it will take a lot of time. But if she asks the sample,
yes,
she will take the largest number. Okay, like she will use democracy.
Democracy.
The rule of the majority over minority. So.
The role of majority over minority. Okay, thank you. Let me, somebody is raising a hand against your answer. Why? Grace.
I'm not against her answer, but okay, I'm not supporting, I'm not against.
Okay, you are in the... Okay.
Okay, I'm saying that she'll have to use the census method. She'll have to ask the whole class, not choosing samples. Reason being, even if favorite color is qualitative data, but still it is specific. Everyone has his or her favorite color. Like for example, I can say you like purple, pink, blue, red, yellow. So we all have different colors. It doesn't mean that we have the same. So some method won't work. No, I mean
okay. Now we agree that the census is very expensive and difficult to conduct. Not so? But now, how do you think about a student if a class is 20 people? Is that burdensome?
No. Hey, 20 is very few.
That means if whenever it's burdensome.
No, you should think of that. Wow.
Okay, now, fine, that's great. But for some, let us accept that for very small samples, you conduct the census type of data collection. That means you use the entire sample, not so, because it's very small. Now, let's look at all these methods here. What makes you to choose an observation method in research or collecting data? What makes you to choose this? What type of activity needs such data?
Examples.
Yes, maybe in form of examples. Yes, Grace.
I can say, like, for example, we can observe people mining or doing some work, like work that you can't do.
Recording events happening. Thank you very much. Now, here, this we say this is carrying out what? A survey. A survey. Like, which type of information could you collect from using a questionnaire? Yes.
The age of people.
Ages. How old are you? That means I will request you to go and design for me a simple questionnaire with a simple topic of interest. Yes? Even in a tour you can use a questionnaire. Yeah, that's very good. Researching and watching videos. You can watch videos about events taking place as you record. It means you can watch a video about an experiment. Okay, thank you. Let me read for you this question. How do you collect data to answer these questions? Part A. That means you should choose for us the method there with the reasoning. How do you collect data for this? What for these questions? A. What is the favorite food and drink of the students in your class? What is the favorite food and drink of students in your class? You can remind us on that type of data and also how you are collecting such, which type and which method is proper. Let me have Nantale featuring, feature and Lucy. Qualitative data.
And you would use the census method.
You'd use the census method. Census is a population.
You're saying among the other ones?
Yes. Use of questionnaire. That means carrying out a survey using questionnaire. Thank you. Okay, carrying out a survey using questionnaires. How about this? Part B. How many cars pass your school? How many cars pass your school in 1 hour? Which type of data will you be dealing with and which type of method? Yes, Precious. Which method would be that?
The type is qualitative.
It is qualitative data, continuous quantitative.
Then the type.
Okay. Observation. Accurate to the spot, but is the data type correct?
Discrete quantitative.
It is discrete quantitative. Could you defend that answer? Why is it?
It's discrete because the number of cars is specific. If there are 30 in an hour, then they are not going to become 31 and a half.
And you count.
Yeah. If the other one is to pass, it will have passed the hour.
I think you pick that. It involves counting and you get a specific number. And you observe by observation. That's very accurate. Lastly, how many times will a dice show a 6 when rolled? Now, could somebody guide us which type of which type and which method? Yes, Precious, you seem to be, Nantale.
I think it is discrete quantitative.
It is discrete quantitative. Okay? Discrete quantitative. Why?
I think it is discrete quantitative because those number of times are counted. And you're going to use the observation method.
Observation. Are you sure you'll put a dice here and look at it?
No, you will observe if someone tosses it. The number of times the 6 shows you counting.
People are putting hands against your answer. They seem to have to be contrary.
The method?
The method is?
Experiment.
Could you give a reason?
Because obviously you will have to first experiment that thing that you want to do. That's data. You have to first.
She's trying to defend her answer.
Teacher, I'm saying observe because if that person, you have to see. What if you look aside then a 6 passes and you think it was a 5?
Now, this is a small debate. Could you defend yourself?
Experimentally now, like I want to know the times the 6 can be on 12. So I have to first experiment. I have to
keep rolling.
Yes. But you have to observe.
You roll, observe. Which is which? help us, Grace, to seize the fires.
Okay, teacher, for me, say how many times, if the kind of data for the times the dice will show a 6 when rolled, I think it is, no one should do it, people please, I'm begging you. I think it is.
You are seizing the fire, not so.
I think it is continuous.
It is continuous. Quantitative method.
And the method, you can use observation.
You are in line with patience.
But not the first one. It's discrete because you're going to count the number of times.
She disagrees with your type.
How many times you're counting? Okay, yes, you're counting, but then, okay, do you count times?
Okay, thank you. It is, we agree that you are going to count.
Yes.
Because the question says how many times, not so? That means counting. And whenever you count, you are dealing with this discrete. But of course, as I'm trying to also fall on this side, that when you get a dice, you try to roll it. You are experimenting while observing. That means we can incorporate the two methods, experimentation followed by
observation.
now.
Now if they ask, which one?
Which the question says which method?
Yes.
Now, which one would work without the other?
Experimentation.
Can work without?
Observation. Because you can't observe without carrying out the experiment.
That means you must experiment definitely.
Yes. You can't observe without carrying out the experiment.
That means an experiment is a must.
Yes. Even the supporting.
Yeah.
No. You can't.
Okay, let us go ahead. Not so. You've supported each other, not so. Now let us go to unknowingly. Let us go to data presentation and interpretation. We've say looked at yes data. Now, after collecting data on your interview papers, because you can have data in form of a table or on the interviews, or you have recorded it in a book, not so? After collecting it, then you have to present it and interpret, not so? Now, which tools are used for data presentation and interpretation? Where can you present? Because you'll have raw data in form of maybe you have interview papers. Some 10 people have said we eat posho. 5 have said we eat rice. How can we summarize our findings and be easy to read them and know what happened? Let me see. Which tools are those that we use for data presentation and interpretation? We can use pie charts to do that. Tally tables. Pictograms. Bar graphs.
Even tables.
Even just normal tables. Then there is line graphs, not so? Aren't they there? Yeah. Now, that means data in raw form is difficult to interpret sometimes because you can find a lot like, let me give an example here. If we looked at the tourists who visited Uganda from various countries from January, February, March, up to April, and here we said those from USA in January were 40, we 20, we 10. In from France, this way 10, this way 60, this way 5, this way 30. From Germany, this way 2, 70, 10, 5. Then if we ask you which country brought the biggest number of tourists, by just looking at that information, is it easy? Yes. You do the addition, of course, but out of direct observation, the information will look vague and confusing. Now, that means the simplest way of easily interpreting it, we can put the entire into a pie chart. We can put it in a tally chart or pictogram form or bar graphs. Then we can know which one is bigger than the other. Yeah, that means raw information is normally a bit burdensome. Now, let us start with looking at a pie chart. And I hope from our constructions and angles, we really, up to this time, we know how to make a pie chart, don't we? Yeah. Now, let me give you this number here on a pie chart. This number on a pie chart, then you can now yeah, 90 people yeah, this is your pie chart. 90 people were asked what type of holiday they had last year. What type of holiday they had last year. And that means somebody went and asked them. The table shows the results of the survey. Yeah, then we can have it in form of a table here. The table shows the results of the survey. Here we have type of holiday, then the number of people. I hope you always go for some holidays and leisures. Do you go for some holidays and leisures? We also left out some data presentation tools, but you'll research on them, called stem leaf diagrams. Stem and leaf diagrams. You'll just do research on them, stem and leaf diagram, then histogram. Yeah, that means do research on those other tools of presenting data, stem and leaf It's not stem, but stem and leaf. Just read about them on internet. Now, the first question of this one, part A. Draw a pie chart to represent the data. Then part B. What percentage of people went on a beach holiday? Now, how are we going to work out that very fast? Yes, Grace, what are you going to do?
We shall have to first find the degrees for each.
The degrees for each. How do we achieve that?
We shall first get the total.
How to get the total number?
We already have a total number of people, which is 90.
The total was given as 90?
Yes.
Yes.
So,
Like if I'm looking for the degrees for activity,
it will be the number of people, which is 32.
32
The total 90 times
times
360
360,
gives us 128.
28 degrees. Okay. City Beach,
27
27
out of 90
times
360.
360 degrees, giving you
That's 108 degrees.
108. Then city break, 7
out of 90
out of 90
times 360 degrees.
360, giving us
28 degrees.
28 degrees.
Then for others, 24 out of 90
24 out of 90
times 360 degrees.
give 96 degrees. Okay. Then there we can construct our pie chart. We agree that it's better begin with the big angles. We said any radius as long as it's reasonably big, not so? It must be reasonably big. As long as it fits in your book, that's the best. Now we said now you first start with the big angle. That's around 128. And now 128 is around here. Now we said just tilt the protractor to add another angle called the 108. Then we go to another angle called the 96. Using the inner scale, 96. Hope you have mastered this. You've mastered that, not so? This is 128, which stands for the activity. Then we go to the city beach. Then we go to the others. Then lastly, city break. Now, can you answer part B? Who is answering that part B for us? What percentage went on the beach? How do we find that the percentage that went on a beach? Yes, Grace, you are ready?
Yes, I can explain.
You can explain. Do explain. Percentage that went on a beach.
Okay, we shall use the very same method we used here when finding the degrees.
Yes.
So it will be the number of people that went for the city beach holiday. That is 27.
That's 27.
Out of the total 90.
90
Times 100.
times 100 gives us
30%.
30%. What if you wanted to use this to get percentages? Is it possible?
Yeah.
How do we achieve that again?
Teacher, I think we can use the method of
That method of how do we arrive? Yes?
108 out of 360 times 100%.
Or 108 out of
360
360 times, yeah,
plus 30%.
giving us 30%. That means since angles are angles, they are in the same ratio. Yeah, thank you very much. Now let us turn to the other tool, which was called let us go to the tally chart. We can also call it frequency table. Did you hear that?
Yes.
Tally chart of frequency. Yeah, and I give you this. Let me just directly give you this question. Tally chart of frequency table. Just write this one here. You are ready? It says here that in a test marked out of 10, the marks obtained by the marks obtained by students were, the marks obtained by students were. Let us just have a small table. Yeah, just have a small table there. You can draw that table and we answer that question. Have you already drawn? Have you already drawn? Yeah, now we write the first question. Write the first question there. Write the first question here. Draw write the first question. Draw a tally chart. Open bracket frequency table. To represent the information. Then, how many students, that's part B, are in the class? How many students are in the class? I hope that one we can have it very fast. Not so? Guide us. What are the components of that tally table? Yes. What?
I think those numbers are the marks that the children got.
The marks. Yes.
Then those.
The tallies. The tally. Then the respective frequency. Okay. We start with which number is the smallest? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. We go and tally 1. We can tally. We start tallying, not so? 3, 1, 3 here, 8, 3 again, 6, 3 again, 4 is here, 1 is here, 4 is here, 9, 3, 5, 2, 3. Now when they become 5, 1, 2, 3, 4, 5. We tie a bundle. Then 9, 4, 7, 5, 2, 10, 5. Now even if you don't tie a bundle, you are not penalized, but it's better to tie so that for large datas you can work with. Now, our frequency table shows that we have 1 tally for 1, 2 tallies, 5 tallies, 3 tallies, 3 tallies, 1, 1, 1, 2, 1. Now, this is called the total. We normally use this symbol, but we can as well call it total or sum. Sum or total of that frequencies. Yes, you've got 20. Summation of frequency is 20. That means you have known how many students are in class. That's what we call a tally chart. Now, let us drop to, you know that we can use a tally chart again to do other things on it, pictogram and other things. Let us pick on a pictogram there, and I give you this kind of table, pictogram. It comes from picture, to represent data using pictures. Now, let me give you two here. Me, I will discuss one, then we ask somebody to discuss another. A farmer planted the following crops. We are on a pictogram. A farmer planted the following crops. The following figures represent the number of the following figures represent the number of crops. Cabbages 5, carrots 4, cassava 6. Use a pictogram to represent the information. How are we going to achieve that? Cassava 5, cassavas 5, 6, cassava 6, cabbage 5, carrot 4, 5, carrot 4. Which symbol should we choose here? A pictogram to represent information. Let what stand for each item?
Let represent carrots.
Like this? Represent. And now the symbol must be for all, whether it looks like how you have said, let it be for each item. We can organize it maybe just look more a bit fashionable. Cassava, cabbage, then carrot. How many cassava do we have?
We have 6 cassava.
Yes, 6. That means I'm going to have 6 what? 6 of them. Then cabbages, 5 cabbages. But you draw similar, they should look the same, not so? How many carrots? 4 carrots. Now, Sometimes if these values are big, if you don't want to draw so many things, you can let each symbol stand for 2. Did you hear that?
Yes.
Alternatively, you can say let that be for 2 carrots. What will be 1 carrot? That means a half. Alternatively, you could say let this be for represent two items, then half will represent, or we could we shade it to shade one side, because as long as you can show a difference, whether half or shading, represent 1 item. Now, again, cassavas, how many am I drawing?
Drawing 3
full ones. That means there is no big deal there, 3 full ones. Then cabbage,
6 full.
I'm drawing how many?
3.
Oh, yes. You let me first error, not so. Cabbage is how many am I drawing? 1 of these.
Not you are drawing 2
2.
and a half.
And the other one which is shaded. Carrots I draw 2. Yeah. That means you decide how many, if there are very many. That fine? That's fine, eh?
Yes.
Yeah. I want to give you one here. Are you ready?
Yes.
The learners in a class were asked how they go to school. The learners in a class were asked how they go to school. Can have it as method of walk, method of walk, method of travel, method of travel. Then tally, frequency, we are right there, not so? Walk, you are going to help me fix the tallies. We can group them, not so? 5, then 4. Instead of writing them at once, we can group these as 3, then the rest you can group, not so? Finished already, even the total? Total is 30, yes, 30. Sorry. Now it says here that illustrate the data on part A pictogram pie chart, then part C, bar chart, part C, bar chart or bar graph. Now that means I'm not going to talk about the pie chart again. Who can help us, guide us on a pictogram there? What should we decide about people? Pictogram, what can you help me with? Yes?
So we can use one man.
Let
one,
a picture of a command.
Yeah, one.
Like this, eh?
Represent one land.
Represent?
Okay. It's 3 learners.
We use it for 3.
Yes. Okay, 3.
3 learners.
Yes.
Okay, then?
Then.
Will it really fit your scale properly?
Because all of them are multiples of 3.
And you've dodged the other one, no?
Using half mean.
Yes. You dodged the half man. Yes. Then bike. Then bus. That means you can fit. How many? Who walk? There are 9. Shall draw 3. That means you fit for me the rest, not so? Grace, you are puzzled about that? Eh? Don't be puzzled, Grace. Okay, hurry up and we go to what we call the line graph. The bar graph, are you right there? Because I've seen there is a question of a bar. I would also wish that why not also put it on a what? On a line. I think we can. I through?
Yes.
I think let me give you for the line on its own here. Bar graph, get out the graph paper or graph book. Now the bar graphs are for, listen, bar graphs are drawn with the bars not touching each other. Which type of data, which type of quantitative data would be speaking about such isolated bars?
Continuous quantitative.
Continuous.
Continuous.
The bars are drawn separate, standing on their own. Continuous means you do continue. Yes, you do think. I hope these ones you filled, not so? You filled because here you drew how many on the bus? 4. That's great. That's right. That means I will not draw the rests. I will not draw the rests. Now we got the bar. Have you got out a graph paper?
Yes.
You remind me of how shall we choose this. I think on your graph paper, one here. This graph paper, it is wise that of course the title, not so, the title, then leave at least two boxes this way, 2. Unless you see that it's not fitting, you can now adjust and leave 1, but leave 2 and leave 2 down. Not so. Then we are going to choose now which scale is going to be here. How are we going to feed in? Frequency is going to be, hope you have got out your graph paper. Have you written the title? A bar graph showing. A bar graph showing, what did the question say? Yes, write that one. A bar graph showing the method of travel. A bar chart or graph. Method of travel of learners in a class. We said leave 2 boxes, not so? On your graph paper. Then down, because mine I'll just have to end somewhere, knowing that now we are going to select what are we going to start to seeing that the last value is 12. The last is 12 and the starting one is what? Is 3. Where are we going to start from? If we start, we say the best is to use two boxes. Don't use 1. That means after 10 divisions, you label. You label here 2, 3, 4, 5, 6, 7, 8, 9, 10. Down here you are saying, well, if we counted 1, 1, does it fit?
No.
It can't. Count vertically. How many boxes are vertical on the graph paper? Will it fit on the graph paper? How many if this is 0? 1. How many 2 centimeter boxes will be there? Can you reach 12?
No. Unless you don't leave this down the space.
You even don't leave any?
Yeah.
Then we shall use 2 for every, knowing that 1 is in the middle, but don't label it to avoid squeezing what? Things. 2, 4, 6, 8, 10, and 12. That means label that on your bar chart. You have labeled 2?
Yes.
But there is a jump somewhere that I've seen it there where you have made a mistake on 3. 2 to 4. Now, down here you label frequency. Then down we label method of travel. Now, how many items are we plotting? We are plotting 1, 2, 3, 4. And each down here has one. Try using 2 centimeter boxes. Does it fit? If you use the 2, remember you are jumping equal intervals. If you plotted here, does it fit?
Yes.
And you jump more to seem to fit. If it doesn't, we shall skip 1 box.
It fits.
2 skip. Now I'm saying that 2 always for a bar graph might not fit down. You can use 1. You use 1, you skip this. Use this, you skip this. But since these are only 4 items to plot, 2 would be better, not so? That means you do plot the first bar runs from up to 9 for walking, That means you locate 9 is somewhere here, and with this, then you plot that, you draw that bar there.
Using a pen or pen?
Plotting is better with the pencil to avoid the errors, unless you can plot with the pen without any error. If you can plot without any error, good. But if you know your hand has errors in it, then use a pencil. The next bar, no need to shade in math. No need to shade, that's geography. Because some of these bars we use them for other things. Now we go to a bike. Bike, jump another equal to, go to a bike. Bike goes up to 3. Hope you have fitted the bike. Not so? Yes, go on and fit. This is walk. That's walking. Then this is a bike. You continue and continue and finish up those bars. Now try to summarize, and we try to look for where to end. Yes?
I have a question.
Ask.
Do you put the scale on the side and the side?
No, you put on only one side, here and down.
Is it a must that you have to write the scale?
Up here?
Yes.
Because now you see, down here it would confuse you. What are you going to say? If you write this scale down, for graphs of numerical values down and up, you can write. Or months, down you'd say 2 centimeters represent maybe 1 month. It's wise to put. It's wise to fill everything necessary for the graph. It shows wisdom. Let me have yours and I look at it here. Yes. The scale, where? Up there in the corner. How will you fit the horizontal one? Okay, let me have this. Yeah, this is very, very perfect. Very, very perfect. Now, since these axes, make sure you put arrows. Since they are continuing, you put arrows on them. This is so perfect, so perfect, so perfect. So perfect, so perfect. I wanted to give you data on a line graph here. Are you set to receive data on a line graph? Yes, receive this data, or receive this data on a line graph. Receive this data on a line graph. The price, you are there? The price, now we're on a line graph, and that will be the end. The price of rice per month in Kabubu market. The price of rice per month in Kabubu market was as follows. Kabubu market was as follows. Was as follows. The months and the price. Jan, February, March, can have that, April, May, I don't know if that will fit there, May, July, May, June, July, then August, 23, 25, 26, 24, 22, 21, 26, 30, are you there? Draw a line graph to represent the information, then part B. Draw a line graph to represent the information, then part B. Describe the trend of prices. Now a line graph, draw a line graph to represent the information. Describe the trend of prices. Get down the title first. That means your graph paper is here, a line graph showing
the price of rice per month in Kabubu market.
Okay, the prices of what? Of rice in per month in Kabubu market, per month in Kabubu market, underline You are also going to help me in choosing the vertical scale. In choosing the vertical scale here, I'll just use a sample demonstration here. Sample. Just a small demo. Help me with the vertical choices about prices. Where should do? Now, since now look here. Since monthly how many? These are 8. Not so? 8. And can 8 fit into 2 centimeters? No. Are you sure? You can't say 2 centimeters. We are not going to jump like in. You are not going to skip. If you counted 2 centimeter boxes, do you really reach 8 boxes? 8 to 2 centimeter? Yes. You fit. Now, in case they don't fit, you are to use 1. Not so? Yes. Yeah. Now, that is pretty easy. We are going to label January here, 2 centimeters, February, then March, April, May, June, July, then August. Not so? Now vertically, we shall just start again from what? 0, but our highest is 30. If the highest is 30 and we are starting from 0, where do we really end? Which scale do we use there?
So we can use either 5 or
5. 0, 5. Can 5 won't they be few? This is 30. If you say 5 2 centimeter, how many will you have plotted by 30? This is 0, 5, 10, 15, 20, 25, 30. How many? Look at your graph. Won't it be so narrow? Will it be? Or it will fit? 3. Remember, our scale should be either 4 is catered for when things have worsened. You can either skip 1 or 2 or 5 or 4. No, 3 can't. If you trace, if you plot 3, you'll fail to locate like 4 on the graph. Correct plotting intervals are these or their multiples. We can use these or their multiples, but we cannot of course use 3 or 7 because you'll fail to plot in between. They should be, we are trying to mean, I mean if you don't use it 1, you can use 10 or 0.1. In case, we are not meaning you can use 9, no, we are referring to multiples in 10, in 10, 10, in 10.
For me, I think we can use
2.
The centimeter should be 1.
1. Then that would be 4. If you are saying 2, why not 4 and skip this?
So we use 4 as
Yes, we can use 4, 8, 12, 16. What if in case you needed to locate, I think others, if you wanted to locate like, because these are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you wanted to locate like 7, where would you locate 7? Because this is 8. Decadauna here. Now that wouldn't be 7.
What would that be?
Now.
Because they are 10.
These are 10, but within there you have only jumped what? 4. It's from here to here is 4.
But we don't be counting after.
Until you reach to plot like 20 what?
Teacher, for me I think we should just choose
2.
2. 2. Yes, 2, and it should be
at intervals of 1. You want it to be like that, but you'll still be speaking because the middle of after 4 you have what? 6.
It will be easy to locate. Yes.
Even if you put here 2, the same language.
It will be easy to locate because if there are 5 small boxes between.
You'll divide by 2.
Yes, divide by 2 get the.
But my argument is that if this is 2, why not know that it is 2 and you don't label it to avoid congestion?
Teacher, so for me I'm going to use 5 because 5 is very simple.
You are going to use 0, 5. That's why we said 5 can be easier to work with. 4 is brought in when, if you can. Okay, use 5, 5, 5, 10, 15 like that, 20, 25, 30. 4 is used as an exceptional. Let us try to plot very fast. Now, when we are plotting, we plot in the middle of this. I hope somebody see that.
Yes.
We don't plot here, neither anywhere, but we look for the middle of this. Is that's like if you're plotting 23 in January, you'd plot 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 23 would be around where? Now the easiest way to locate is always let me first see for what is 23?
We shall have to divide.
The easiest way is because you are using a scale of 5, 5 for 10, you'd have to divide 10 by to get 2. Then if you are looking for 23, it is 23 divided by this value to know how many. Somebody with a calculator there, 23 over 2 is 13, 12 and a half. Are we there? 23 over 2 is? Wait there. Wait. This was 5, not so? 5 divided by 10, sorry. It is the 5 over 10, not 10 over 5. That gives us 0.5, not so? Then 23 divided by that gives you 46.
Yes.
Now 46 you count from here, 46 boxes, which you know this is 10, 10, each is 10. That means 10, 20, 30, 40, then you count more 6. 1, 2, 3, 4, 5, 6.
Okay.
You pick that?
Yes.
You try it. Now you see this, we know. Let me explain it better. 10 small squares are representing an interval of 5, 5, not so? What of one small square? That's what we are looking for. Would be 5 out of, giving us 0.5. Now if you wanted any value to plot, it is this divided by this. You count from 0. But if you wanted to count from 20, again there is something there. Because you can know that 23 is between here. Just get 23 minus this divided by that, you will get 6. And you will count from 20. 23 minus 20 gives us 3 divided by 0.5 gives us 6. That means you will count 6 from here instead of counting 46 from down. 2 ways.
What if you also do like this?
Yes.
There's a time when you work it out.
Yes.
Like 5 out of 10.
Yes. Which is this?
But the one I'm understanding it, like 5 out of 10. Okay, 10 out of 10 divided by 5.
Yes, 10 divided by 5.
You get to.
Then you multiply.
No. So you will start counting 2 boxes and you get the next number. 2 small boxes.
You're right. That's another method. That means if you wanted to count, you'd say now this 21, you count 2.
Yes, 2 small.
That's very good. Yeah. Hope you can locate others. 25 divided by 0.5 is 50. Counting 51, this is 10, 20, 30, 40, 50. Oh, that's 25 is already here. Not so? Now, between here you plot in the middle, but you can plot what? You can plot a dot and a circle, or you just use a cross twice. $25 is exactly here, goes with February. March is 26. Where do I find 26? She gave us another method. 10 out of 5 is 2. That means I'm going to be counting 2, 26 is 2 boxes. Or 26 out of 0.5 gives us around 52 boxes. Yeah. 24, 22, 21, 26, 30. You plot in the middle here. Then you join with a line. That means join with a straight line, since it's called line graph. Put rulers and put not freehand ruler. Okay, students, let us answer part B and we end this topic. Let us answer part B, then we end this topic. It says describe the trend. What do you see? Precious, take us through that trend and we close. Precious, take us through that trend and we close.
So just try it.
Try.
I think there is a rise
In the prices,
and also a decrease somewhere.
a rise in the prices, a and a decrease, then a rise again. Okay, thank you. Prices, don't forget to label the axes, prices in shillings, then months, then indicate our scale in the left hand corner. Have you indicated our scale? Every 2 centimeters vertically in the corner here, where the corner here, that means you label vertical and horizontal. Vertical, we have seen 2 centimeter boxes are representing 2 centimeters represent 5 shillings, not so? Vertically. Then down 2 centimeters represent how many months?
1 month.
Represent each month. Each month. Yeah, the trend is that there is an increase in prices from January to March, then a decrease in prices from March to June, and finally they increase from June. They increase quite rapidly. Here they increased slowly, decreased slowly, increased rapidly to August. And you should be now aiming for this activity of integration. And activity of integration, have it down. The games master, at your school wants to buy football boots. The games master at your school wants to buy football boots. Wants to buy football boots for 3 teams in the school. Football boots for 3 teams in the school. The 3 teams are under 18 years. The 3 teams are under 18 years. Under 18, under 16 years, and under 14 years. The games master does not know the foot size for each of the players. The games master does not know the foot size for each of the players. And the question says, explain how the games master will get the required data. Explain how the games master will get the required data. And how to determine the total costs. For buying the football boots. For 54 players, is there another way? That's another question. Is there another way of getting the required data other than what you have explained above. Other than what you have explained above. Yeah, thank you for attending. We meet in topic 10.